All right, welcome everybody. The submission deadline for the project just closed, and so I hope that you were able to get your project finished and submitted. And I bet it's probably a pretty good feeling to have it behind you. So I'm going to be working on those through the weekend, and I'll grade them as quickly as I can, but I balance that with the desire to really understand the work that you've done and carefully look through what you've submitted. And so it may take me several days or maybe to the end of next week before I grade all of the projects. But I will be looking through those and hope that it was a useful learning experience for you. The next thing that you have on your to-do list is homework number 12, which is due on Monday, April 20th. And we're nearing the end of the semester. Today is Friday the 17th, and we have one more week of class after this, and then the week after that is final exams. And so if it feels like you're just about exhausted and you can't handle too much more of it, the good news is we're almost finished. Okay, today we're going to be talking about inflation, continuing that topic, and looking at specifically how inflation can be related into present worth calculations. And this is information from chapter 14 in your textbook. Before we start talking about this new material, are there any questions?
Hey, Dr. White, in regards to the project, are you likely to give 100%?
I have in previous semesters.
Okay.
Yeah, the score that I give is largely dependent on the quality of the report that's submitted. In the past semesters, there have been quite a few students who've gotten a perfect grade on that. It hasn't been rare, but it hasn't been everyone that got 100%. I'm not going to give the same grade to a student who clearly has read the assignment and put a lot of effort into the research and their calculations are all correct. That person wouldn't get the same grade as someone who didn't get all the calculations correct. Let's say maybe that they've compounded their cumulative savings balance wrong, or maybe they just pulled numbers out of thin air for the expense estimates and things like that. So in the past, there have been a wide variation in the effort that students have put in, and the grades have reflected that accordingly. All right, so today we're going to continue talking about inflation, and this is a timely topic because one aspect of inflation is related to how secure people feel in their employment. Because when people are earning a lot, and when the job market is tight, meaning that employers are having a hard time attracting new employees, then they increase the wages, and that means there's more dollars in the economy and prices go up. But right now we're kind of in a much different and unprecedented position where over the past 4 weeks, 22 million new claims for unemployment have been filed. And so the figure that you see here on the screen is taken from the New York Times, posted I think just yesterday, based on data that's gathered by the federal government, the Department of Labor Statistics. And if you compare the historical unemployment claims, even through the period of the last recession that we had, the financial crisis, as they called it, back in 2008, that arose due to lending practices and mortgages to people who probably shouldn't have had big loans because they didn't have enough income to justify those loans. So that so-called crisis never even broke 1 million claims per week. But over the last several weeks, we've seen the jobless claims $3 to $6 million per million people per week. And so we have a lot of unemployment. And consider what that does not only to the number of dollars that are circulating through the economy, but also the confidence that people feel and how willing they may be to spend those dollars on big purchases like a new car, or on frivolous purchases like a drone, or even decisions like whether to buy new clothing or continue wear the old stuff that maybe you're a little bit tired of but still fits well and isn't necessarily threadbare. So the idea is that through periods of economic turmoil, occasionally we can have situations where rather than inflation, the economy experiences deflation. And so inflation, remember that we've been talking about, is that prices are going up over time. Deflation is the opposite of that. And it can arise because of troubling economic conditions like high unemployment. And deflation is a reduction in prices over time. And there's something called a deflationary spiral, and we're going to talk about a deflationary spiral, and that is where the prices are going down over time, meaning that money is becoming more scarce or more valuable. People are being more selective in what they spend money on and more cautious in how they spend it. Now, let's go through this deflationary spiral and understand how it feeds into itself. There's no one single place that a deflationary spiral begins, but we can jump in just on the idea of falling demand. Now think about right now, the circumstances that we're in, why demand for things might be falling. And so there are direct reasons, like you're not using as much gasoline because you're not traveling as much as you have in the past. And so gas prices have been going down, in part because people are buying less fuel. But it's not just fuel, it's demand for things like food in restaurants. You're spending less money in restaurants than you did before. You may be spending less money on clothing and on electronics. And so there's a handful of things that demand is going up for, like toilet paper or Netflix maybe. But in general, demand is going down. And so what that does is it causes prices to fall. Why do prices fall when demand is falling? Because it's the only tool that a reseller or a manufacturer has to try and stimulate demand again. So remember, our price-demand relationships told us that when demand is going down, the only way to try and stem the tide of that is by decreasing the prices. So prices are going down, and now the risk is that the people who are selling things may default on their debts, because the production lines and the rent that has been taken out, the loan that's been taken out to renovate a restaurant, for example, all of that was predicated and planned on a certain number of items being sold. And so if you're not getting as much revenue coming into your business, you have the risk of your debt defaulting. And when you default on your debt, that may force other people into bankruptcy. And so if you're not paying your landlord, if a restaurant isn't paying their landlord and isn't paying the people that they owe money to, like they may have previously had a balance running with their liquor wholesaler or with a vegetable delivery business or with the people that provide their linens, or any number of creditors may not be getting paid, and so now those people aren't getting the revenue coming into them that they were expecting, and so now it triggers layoffs because you have less revenue coming in from the people that were supposed to be paying you. You can't pay your employees, and so now that just adds to more people in the pool of unemployed who are earning less money, and then that further stimulates the falling demand. And so it's called a spiral, a deflationary spiral, because this process is kind of vicious, that for each person who newly becomes unemployed, they spend less, then that suppresses demand even further. So one of the reasons why these stimulus checks have been going out over the last few days is to try and stem this deflationary spiral by pouring more money into the economy and hoping to prop up demand for things, hoping to prop up people's perception of how stable the economy is, and try and break the cycle, because deflation is even more insidious than inflation is, because it causes people to have this perverse incentive in your mind. If you know prices are going down, if you know that gas is going to be even cheaper tomorrow than it is today, then that makes you put off your purchase. And so then that further contributes to the deflationary spiral, is the expectation that prices are going to be decreasing, then you put off purchases further. So it's tricky. So we're going to be talking about the relationship between different interest rate types. And in class before, I introduced this formula for how we can understand the relationship between market interest rate, which is the interest rate that a bank will actually pay you, with the I, which is the inflation adjusted interest rate, and F, which is the inflation rate. And so we have a couple of problems we're going to be working through in today's in-class exercise to look at how does the amount of interest that's actually paid by a bank either increase or decrease your purchasing power over time. And the reason why your purchasing power could decrease over time is that if you look at what interest rates have been over the last few years, they've effectively, on a real basis, gone below zero. So the interest rates on an effective basis, you see this axis is saying expected real interest rate. If the market interest rate, which is shown in this figure, if the market interest rate is below inflation, then that means that the rate the bank is paying to you can't keep up with inflation, so that your money is actually becoming less valuable over time. So that's unfortunately the situation that we've been in through since about 2008. Since that last financial crisis, it's been very difficult to find savings accounts and CD accounts that were paying a positive real interest rate. Now, banks pay the market interest rate, I sub F. That's just what they advertise, and they don't necessarily promise that their interest rate will beat inflation. It may be that their market interest rate's more than inflation. It may be that their interest rate that they're paying is less than inflation, and there's consequences of that. If you hope that the market interest rate you earn from your bank, you hope that it's more than inflation so that your purchasing power can go up. And we talked about purchasing power in class on Wednesday with that basket of goods. And we went through a calculation that showed that that basket of goods that costs $25 now is going to be more expensive in the future. And what an increase in purchasing power will allow you to do is buy more baskets in the future than you can buy now. So that was the case where if you had a real interest rate that's positive, your purchasing power goes up. But banks seldom quote a real interest rate because they don't want to draw attention to the fact that the rates they pay may be effectively making your money less valuable. The other practical reason for that is that inflation is always changing, and so they know what they pay. They know what they're paying you, but they may not want to be in the position of having to constantly change their estimate of inflation, and so they just quote I sub F. So there's two ways to work estimates of inflation into an economic analysis. One of the ways is to convert the cash flows into constant value dollars. And so constant value dollars means how much would it be in today's terms. So you'd take a cash flow diagram and you discount all of the amounts in the future at the rate F, meaning at the inflation interest rate. And then for whatever real interest rate you want to achieve, so now for I, in this bullet point here, the I that we're talking about is, what rate of increased purchasing power do you hope to achieve with this business or investment opportunity that you're embarking on. So you'd separate out the two variables. You'd discount the amounts to the present at F, and then you'd do further calculations using the real interest rate I. The next approach would be to leave the cash flows as inflated dollars, meaning that the amount in the future isn't being reduced for the inflation effect, but then you'd use an inflation adjusted interest rate, I sub F, in all of your calculations. So you'd combine together the effective inflation and also the real interest rate you want to make out of that business opportunity. You'd combine them together, and so just all at once discount with a single rate, I sub f. There's also the question of how inflation effects factor into capital recovery. And remember that capital recovery is the calculation that's performed to understand the annual cost of owning equipment. And so when you've calculated capital recovery in the past, it's been the annualized difference between the initial purchase price and then some future salvage value, which is usually a return to you some years in the future. So the way that we would use inflation and capital recovery together is that the money that you're getting in the future is less valuable than money that's being received today. And so the capital recovery amount, the amount that you're earning to justify some present outlay of cash, you should use the interest rate I sub f in order to do the capital recovery calculation. So in other words, if you know you want to make I, you have to take into account f, because f is going to be eroding your real rate of return. So use I sub f in this formula. So this is the formula, the ratio A to P. So if you'd find an annual equivalent of some present initial cost, what this is saying is substitute I sub f in this formula. Now just to illustrate both of those ideas, let's take a look at the in-class exercise. And I emailed this out earlier today, a PDF file that has our in-class exercise for today. Let's begin with part 1. Let's say that your bank offers, quote, the nation's highest yield, and that's actually a claim that one of my banks makes. The nation's highest yield on its money market account. They're so proud of this money market account that's paying 1.25%. However, you know that inflation is 3%. So how could you get inflation data? Well, there's a lot of different ways. The government keeps pretty detailed statistics on how the price of things are changing over time. So you could go to that Bureau of Labor Statistics resource and find out that F is 3%. So if we're interpreting this problem statement, the rate that the bank pays I sub f is 1.25 and f is 3%. So if you're putting in $110,000 and leave it for 8 years, the steps that I'd like you to go through is, first of all, calculate how much amount there will be at the end of the 8-year period. So here in step A, you're applying the bank the I sub f, the bank paid interest rate of 1.25, to find out how many dollars are there at the end of the 8 years. And then in step B, you're going to calculate the present value of those dollars. And so the amount that you found in step A, discount that from 8 years in the future to the present, and it says here using the inflation rate. And then finally in step C, calculate the real interest rate. So calculate I in this formula, because we know I sub f and we know f, so solve for I. Okay, so I'd like you to do steps A, B, and C, and then if you finish all of that, you can get started on B, but B is a little bit more complicated, so it's something that I can illustrate and we can discuss together. But I'm going to pause the recording, stop talking for a few minutes, and give you some time to run the calculations on step A, B, and C to find these amounts. Okay, let's look over some of the calculations just to see if you're headed on the right track. So in part A, you're asked to find the accumulated amount using the interest rate paid by the bank. Okay, so the amount that the interest rate that's paid by the bank is I sub f. So I sub f, the market interest rate, you can see that if we use the 1.25% that's paid by the bank, then you compound into the future the 110,000 that you're depositing in the bank today. It's going to be compounded for 8 years. Then that means the number of dollars at the end of the 8 years will be 121,493. So that's how many dollars you have, and that sounds good. You know, you only put in 110,000 and you're taking out 121. So if you didn't know anything about inflation, that would seem just fine. But you do know about inflation. So the real interest rate that's offered by the bank is going to be lower than that, because if we look at what's the present value of those dollars. So in part B, it says determine the present value of the accumulated amount. So here in blue is the accumulated amount. So what's the present value of that? Okay, so we're going to use the inflation rate of 3% and take that 121,000, which is in the future. That's 8 years in the future. How much is that worth in today's terms if it's discounted at 3% per year? So we rearrange the P to F relationship, and this time we're going to solve for the present value, and you can see that the present value is only 95,908. And so now it doesn't seem like such a good deal, because how much did we deposit to begin with? You deposited 110,000. And so 110,000 turning into 121,000 sounds great, except that it's actually like losing money. It's like that 110,000 is being turned into 95,000 because the purchasing power is less in the future. Because although you'll have more dollars, the cost of everything that you're going to be spending those dollars on is greater than it was before. So you'll have more money, but everything you want to buy is even more expensive. It's proportionally higher prices. And the way that we can know that is in part C, we calculate the real interest rate. So I sub f is given, and the inflation rate is given, but what we want to do is solve for I, the real interest rate. And you can see that I've begun to do some algebra here. Let me not take it all the way through yet. Give you a time, if you haven't already, to calculate what is the real interest rate. Okay, so if we substitute in the 1.25% market interest rate, subtract out the inflation rate, and then divide by 1 plus f, which is 1 plus the inflation rate. The sad truth is that we have a negative value, a negative real interest rate. So that means that your money is losing 1.7% of its value each year it's in the bank. And it's not just if it's in the bank. Anytime you have money someplace and it's not growing at least as fast as the inflation rate, then effectively you're losing value. And I'm experiencing that right now. For instance, the money that I have in my checking account. My checking account pays no interest, and so it's losing value over time. And you're probably experiencing it as well. If you have money in your wallet, cash dollars in your wallet are gradually getting less and less valuable because prices are going up, and you don't earn any interest by having money in your wallet. It stays the same number of dollars now and in the future, unless you're earning more money, or unless you have a magic wallet, and I don't. All right, so any questions about this part 1 that we've done so far? All right, now the fourth question was asking, what is the inflation adjusted interest rate would the bank have to pay you if you wanted a real interest rate of 1.25%? So what that means is, this time we're solving for I sub f. So in this formula, part D is saying if you want your real interest rate I to be 1.25%, then how much do you have to earn from the bank? So solve for I sub f if I is 1.25%. And so if we want a real rate of return of 1.25%, then that means the bank, we should be looking for some bank that's offering 4.29%. That's what we'd have to make. And then inflation would take 3%. That would leave left over for us 1.25% in real interest. So it's absolutely critical that you understand the difference between real interest and market interest, because what's paid by the market isn't going to necessarily increase your purchasing power. Okay. The second part of the in-class exercise is posing the scenario if your company is investing $550,000 in a new crane. Okay, let me bring that up down here. Maybe it's a little more clear. All right, your company is investing $550,000 in a new crane. How much revenue must you earn each year to recover the investment in 5 years with a rate of return, real rate of return of 9% when inflation is 5.5%? Assume no salvage value. So this is showing us how we can account for the fact that the dollars you're earning in the future, that's paying off this equipment, are less valuable than the dollars you spent to buy the equipment. So this example is telling us that we want I of 9% and F is 5.5%. So the first thing you're going to have to do is calculate I sub F and then solve for A, because we know the P is 550,000. So use the 550,000 for the P and then substitute I sub F into this formula. The I sub F that you've calculated here in this first bullet point, use that as the interest rate that goes into the formula. And then find out how much would your company have to receive each year. So again, I'll pause for a moment, give you a chance to do your calculations, and then we'll take a look at the solution together. Feel free to interject with any questions if you've got them. Let's first of all look at what is the I sub F that should be used in this. So if we're going to be spending $550,000 on the crane, and we want to achieve 9% real return when inflation is 5.5%, you can see that what we're going to have to discount and do all of our interest calculations at is 14.995%. So it's the real interest rate plus the inflation rate plus the product of the two. So this is the factor that you should put into this equation to find the ratio of A to P. So use this interest rate in this equation and multiply it by P. So 550,000. All right, so let's look at the final answer for this one. So here is where we are making the substitutions of I sub f into the equation. And so if you multiply 550,000 by, in the numerator, that works out to 0.3031, so that's the product of this one. And then in the denominator, 1.01, so that means that each year you should be trying to earn $164,000 from that equipment in order to justify its initial purchase. So if you have that much coming in, then that means that the effect of inflation, the fact that the dollars you're earning are less valuable than the dollars that you spent to put the equipment into service, inflation's been factored in, as well as the rate of return that you hope to achieve. Any questions about how to do this one, this second part of the in-class exercise? All right, well, that takes us to the end of what we're going to cover today. Before we go our separate ways, let me just remind you that homework number 12, which makes use of these inflation concepts, that assignment will be due before class on Monday, April 20th. So you've got the weekend to kind of apply those inflation calculations to the assignment. And if you have any questions, you can send me an email, or we can set up a time to talk. So that's it for today. I hope you have a nice weekend, and I will talk to you on Monday. Bye-bye.